Welcome to the Honeypot Project. We're here today for our first build video. It's been an exciting month. We've had several attacks on our honeypots, so we're going to dig right into it. We're going to be talking about nasapol.com. We're going to be talking about Stratum coin mining. We're going to discuss our Cystic and Falco high interaction honeypot that we deployed, and we're also going to discuss the elk stack that we deployed. Elk stack is Elasticsearch, Logstash, and Kibana, which is used for virtualization of log files. First, we're going to go over the attacks that we had on our cowrie honeypot sensor. We discussed the deployment of cowrie in our last video, so we're not going to go over that again. We're just going to dig right into the interactions that we had. On February 13th, we had an attack from a Romanian IP address. This was the first in a series of attacks. This lasted for 29 seconds. Then on February 19th, we had another Romanian IP address. This attack lasted for 103 seconds. A little bit later in the day, another Romanian IP address. This attack lasted 180 seconds. And finally, for this attack, we had one from a Moldovan IP address, and this lasted for 174 seconds. Then on February 20th, we had a kind of an unrelated incident. This lasted for 101 seconds, and this came from an IP address in Poland. We use geolocation to find where these IP addresses are. Most of them are in Romania or Moldova. The ones in blue are related to one group of attackers or attacker, we're not sure. And the second incident that came from Poland is unrelated. We're going to first begin to talk about the attacks that came from Romania. Okay, so we're going to start by playing back one of the most important log files. This is midway through the series. Right now the attacker is trying to use the wget command to download a script from his web server. Tries to run it, nothing happens. So he's going to escalate to a root shell. And I think at this point he believes that Perl is not installed, so he's going to install Perl. Remember that we're in a virtual environment created by the cowrie honeypot. So these scripts are going to fail regardless. That's a feature, not a bug. So he tries to run this script again. He gets a segmentation fault. However, he thinks that Python works, so he's going to download a Python file, a different script from his server here, nasapol.com. He tries to run this script, it doesn't work, so he verifies that he's downloaded both the files. Perl keeps giving him a segmentation fault. Tries to download Perl again. Maybe he thinks that because he's now in a root shell, that will make a difference. Still gets a segmentation fault. Finally, he checks to see how much free memory he has, and then he quits. Okay, so I took a screenshot of the website nasapol.com. He also has his own YouTube channel where he shows you how to perform DDoS attacks and take over web servers. This is the files that we saw that were downloaded in our playback of the interaction. So what I did was I downloaded these files myself and took a look and seen what they did. We can open up the v.py, which is a Python script. It looks like it was stolen from somewhere else because if you go through GitHub, you can see this code. This code is quite common. What this does is v.py, which is one of the files that he downloaded. This is a speed tester. And what this does is this goes out and tests the actual bandwidth that the server that you're on has at speedtest.com. And then it will come back and tell you what the actual bandwidth is. Very simple file. I guess if you're going to run a DDoS attack, you would want to know how high you can throttle the bandwidth, what it can handle, and this script will do that for you. The first script that he downloaded was just a bash file. It's a bash script, and what this does, this is called ninfo. And ninfo will tell you info about the machine that you've taken over. It will tell you what the CPU is, it'll tell you what the OS is, the version of the operating system, how long it's been up, and it will also print all this information out in nice colors for you. And then it will go down and download the speed test and give you the speed test results. The file on the web server that launches a DDoS is called Paul. Paul is a Perl script. I believe that this was also probably stolen from somewhere else. Given some of the comments are in English and then anything he seems to write is in Romanian, it looks like what this does is basically launch a DDoS attack. You get options of what's the port, what size packets you want to use, what the bandwidth to consume is, the time to run, the delay between packets, and that's what this file does right here. There is some Romanian instructions. I've read through these. It's nothing too different. At the end we run this send flood with the packets to flood, the address that you want to go to in the port. Another interesting thing that I found on his website was the password file. The password file here, these are the passwords that his scripts will use. Typical ones are Oracle, Git, root, and then you can see a plethora of root passwords here that it goes through. Our Honeypot will obviously accept any of these because that's what his point is, but these are the passwords that his bot goes through, his scripts go through and try to use to get into your system. And once he's there, it looks like he's going to launch a DDoS attack against another site. Okay, so now what we're going to do is we're going to test NASA Paul's DDoS attack out and see how effective it is. Currently I have a virtual machine running Apache and WordPress on Apache installed here, and we're going to start pinging this server. As you can see, the time is anywhere between 5 and 10 milliseconds, sometimes slightly higher. And now we're going to run against this server NASA Paul's DDoS attack and see if we have an increase in latency, and it's quite staggeringly that we do. The time has jumped all the way from 5 milliseconds to 131 milliseconds, sometimes higher, sometimes as high as 373 milliseconds. This is definitely affecting the pings. Here we got some requests timed out, actually several requests timed out now, and the latency has dramatically increased. You could see that if we were to use several different machines in this attack. It actually launched a full-fledged DDoS attack, like a distributed denial of service attack, that we would probably take down this system quite easily. We're now going to talk about the second attack, the attack that came from the coin miner. His agenda was to mine cryptocurrency. We're going to watch his playback. It's rather short, but it's very effective and very sneaky. He logs in, goes to the temp directory, downloads a file, and then he's going to change the permissions to make it executable and run the file. Now that didn't seem like he did a lot there, but what he did was very, very sneaky, and we're going to dive into that now. Okay, so what we have going on here is this is the file that he actually downloaded. This is a shell script, and what this does is it goes through and it removes any previous copies of index.back or index.back that he's downloaded. It removes any HTTPD configs that he's downloaded previously, and then it goes out and downloads the file that you need to run to do the mining, and then it starts the mining. What's particularly sneaky about this is the file names that he uses and where he places them. He uses the file name index_back. Now that could be used for any website. You have put it in the temporary folder perhaps, where you have a backup index file for your website. httpd.config, that's Apache's configuration file. That's very common to keep a backup of also. Temp seems like a logical place to keep this. So it's very, very sneaky where he's putting these files. Very sneaky. And if you were a systems administrator and you were just to look over and double check your temp files, you might not notice that either of these files are there. And what's more is that they are going to be deleted after the execution is finished. Now the actual miner is here. It's running this script, wget, and then it goes out to this server that he's probably taken over, and grabs this httpd.conf. After it grabs the file, it changes it to executable, runs the file, and then after it's done, it's going to clean up. So this stratum, you might see here, and I looked up what stratum is. Stratum is a mining protocol for Bitcoin and other cryptocurrencies. And what stratum will do for you, this protocol, instead of using like the standard mining protocols, that you can do distributed mining, meaning you can have various nodes working together to mine coin for you. So that's a little bit different than having just like a singular machine mine Bitcoin. From using this, you could have like 1,000 computers all working to mine Bitcoin for you, together in tandem, to give you a better chance of getting a reward. So that's what this attacker has done. It was quite sneaky, no less, and this is the reason why this guy probably even bothered was he was probably just trying to run this on as many machines as possible. Probably didn't pay any attention to this is a honeypot. This is not a honeypot, because this is rather a little bit more sophisticated than the last one. We start talking about our new honeypot. This is a high interaction honeypot. The cowrie system that we have set up currently, that is a medium to low honeypot. That uses a virtual machine that doesn't give full functionality of an operating system to an attacker. So there's a limited amount of information that we can capture from a medium or a low interaction honeypot. So that's why we needed the high interaction honeypot, so we can get more information. The way to do this is to use Sysdig and Falco. Sysdig Falco, it was started off as a security monitoring software for containers in Docker specifically. Um, so what is Sysdig? Sysdig is an open source tool which can capture and save state information and activity from a running Linux machine. It is easy to perform an offline analysis of the process, network, and I/O activities that took place. Falco is an add-on to Sysdig, and what Falco is a behavioral activity monitor designed to detect anomalous activity in applications. Falco can detect and alert on any behavior that involves making Linux systems calls. So that's what we're doing here is we have a actual high interaction honeypot. It's a real operating system. It's not a virtual operating system that was created by our honeypot sensor, and we are monitoring this honeypot constantly. A couple things that were different about this deployment against the previous deployment. This deployment we use Chef DK. Now Chef is a utility that allows you to deploy applications and containers consistently. Basically, the Chef has a cookbook, the cookbook has a recipe, and the recipe deploys your software. So we use that to put Sysdig and Falco on the system. The image files that Sysdig is capturing are stored here, and these are stored images of the file state, or the state of the file system. FileBeat itself, you might see here, FileBeat is used to send our logs currently to our Elasticsearch and Kibana server. The reason why we're interested in that is because Elasticsearch, you can do some regular expression, more complicated regular expression searches and analysis on the data that we're collecting in our log files. And Kibana can visualize the log files, what we're looking at. So we've currently got this set up. We haven't had a lot of activity going on yet. I will show you a little bit here as far as authorization attempts. You can see here from our server we're capturing real-time information on what the username that they're trying to use and where they're logging in from different IP addresses. You can see here, just looking at some of these log files that Falco is coming up with, we're seeing the different usernames that are quite common, such as FTP user is a very common one, admin's a very common one, Pi. This might surprise you, but this is a very common one. That's the default password for a Raspberry Pi, or default user for a Raspberry Pi with the username Pi and Raspberry as the password. So that's very common. You can see these are probably bots running through their password list and attempting to log into the system. So the next thing that I'm going to show you is our Elasticsearch and Kibana server, where we're sending these logs to. What I want to demonstrate is our Elasticsearch service. This is also using Amazon. Once again, big fan of Amazon. A lot of this stuff is free, including this Elasticsearch service that you can run for 12 months. So we're trying to visualize our data. We've been having some problems with that, which I'll go into in a little bit. You can see the indices here. These are FileBeat instances on our servers, which are sending us log files. This Amazon service has monitoring and logs of its own. We can go straight to the Kibana instance. Now, using Kibana, we can do the same search that we did on the command line, looking to see invalid users, and you can see that it's quite a bit more simple than running these commands from the command line. We can look through these log files. We can run regex searches. Kibana has its own query system using Elasticsearch so we can aggregate and analyze these logs a little bit easier. The goal is to visualize them. However, we've been having some problem getting the geolocation to work. So once we get that going, though, I should be able to visualize on a map where these attacks are coming from, what kind of attacks that they are, and colorize things. So that's one of our goals for down the road, is to get the visualization to work. Right now we have Kibana working and we have log files being sent to Kibana. We do have a couple problems. This is probably like the biggest part of the problem, or the biggest problem of the project right now, is probably working with Kibana and Elasticsearch. It's kind of a pain to work with this in Amazon because you have to use SSL certs. So you have to set up certs for your own servers, and then for the Amazon Elasticsearch server to get it to work, because that's working over SSL instead of sending unencrypted logs back to the server, to the Elasticsearch server here. So it's kind of difficult to set up. I have it working now. In the future, I would like to get it to filter the log messages coming from the servers a little bit better, and then once they get in here, that'll make them a little bit more palpable to search through. So that's what we have going on for this month. We've had a couple other little side projects that maybe we'll have a little bit more time to talk about next time, and we're going to go over the rest of the rubric. So, okay, so I think we're going to cover the rest of the rubric now. Work completed by team members. If I haven't stated already, this is a solo project once again. So I try to go a little bit more in depth into the demonstration. The problems encountered. Once again, I ran out of room on one of the servers for the logs, and Cowrie crashed for a couple days. So I had to clear that up. The biggest problem right now with the project is getting the logs off the servers into ElkStack, or Elasticsearch, what's called our Elk stack in Kibana, to get them to visualize. It's rather difficult. You have to, like I said, set up some SSL certs to get this to work. So I'm still kind of working out that aspect of the project. I need to filter the log files on Cowrie and also Sysdig a little bit better, so that I can get a little bit more usable, palpable information on the Elasticsearch server. Once I do that, I should be able to visualize using the GeoIP location. Any changes to the previous design requirements? No. Currently I don't have any changes coming up. For the next sprint, we're really looking at getting the Elasticsearch in Kibana visualized. We're looking at ramping up our Sysdig Falco configuration, and hopefully getting an attack on the server if we can, and then possibly adding a Windows honeypot into the mix if we can. We've also experimented a little bit with UFONet, which is a DDoS system that's used by pen testers, that if we have time next time, we can kind of show that off. And finally, what we have been kind of playing around with a little bit is Glassstuff. That is a web application honeypot, which is pretty cool. So if we can get that configured, we can get that up and show you guys for the next time on the next sprint. So basically, that's what we've done. That's what we've gone over about everything. The only thing that I would wish I had a little bit more time to go into next time also would be botnets, because I've learned quite a bit about botnets and how they operate. So if I can throw a couple slides together next time, I hope to go into a little bit more detail on that too. Thank you very much for your time. Have a nice night.